This lecture is going to be about literate statistical programming. In the lecture about reproducible research, I talked about the basic ideas of what it means for an analysis to be reproducible. But now I'm going to talk about one of the tools that you can use to actually make your analysis reproducible by others, or at least help other people to kind of reproduce your analysis. And one of the ways that we talked about making reproducible documents is with this literate statistical programming concept, or just literate programming. And so the basic idea is that authors have to undertake a lot of effort to put data and results on the web, and even when they put that stuff on the web, they're all kind of separate. The data is over here, the code is over here, and you kind of have to figure out, well, which code goes with which data, and how do you execute this code, and do you have to load this first, and you have to do this first. So there can be a lot of confusion even when everything is just available. And so one of the ways that you can simplify that process is to put the data and the code together in the same document, so to speak, so that people can execute the code in the right order and the data are read at the right times. So you can have a single document that integrates the data analysis with all the textual representations, so the words that you use to describe what's going on, and so you don't have to have everything kind of in separate pieces, but everything is kind of linked together. So the original idea behind literate programming comes from Don Knuth, who was a computer scientist at Stanford. And his original system was for writing just regular computer programs and kind of documenting the computer code at the same time as writing the code. So the basic idea translates over to a literate statistical program where you want to document your analysis and similarly have the code for your analysis in the same document. And so the idea is that an article is a stream of text and code, and analysis code is divided into text and code chunks. And so the presentation code formats the tables and formats figures, things like that. There's article text that talks about what's going on. And then these literate programs, there's two concepts. You can weave them into human-readable documents, and you can tangle them to produce machine-readable documents or just code files. So literate programming, as I said before, is a general concept. You need a documentation language and a programming language. So the original SWeave system that I talked about before, written by Fritz Leicht, used LaTeX as the documentation language and R as the programming language. So on this lecture I'm going to talk about knitr, which supports a variety of documentation and programming languages. And so the first thing you want to start with, so the basic question is, how do I make my work reproducible? And the basic answer to that is that you have to decide to do it, okay? And you can decide to do this at any point in your analysis, but it's usually easiest to do it at the very beginning. If you decide at the very end that you want to make your analysis reproducible, then it often is much harder to do, and maybe even impossible. And so we want to keep track of things as you go along. You could use a version control system like Git or SVN. I won't talk about that here, but if you've heard of that, then it's a good thing to learn. It's important to use software, statistical software, whose operation can be coded. So the idea is that you can write down the instructions that were used to manipulate or analyze the data. So this generally rules out graphical user interfaces unless those programs will code or keep track of all the clicks that you make on the graphical user interface. But systems like R and other types of packages, because you have to program them explicitly, the code, as long as you save the code, will have everything that will store everything that you did to the data. Another key lesson is to not save any output. By output, I mean mostly kind of temporary data transformation types of objects. So if you pre-process the data and have a kind of clean data set, rather than store the clean data set, it might be better to have the kind of raw data set with the pre-processing code, because then you not only can you make the final product, but you can see how you got there. If you just keep the clean data set and maybe you accidentally lose the pre-processing code, then you don't really have a good record of how you got from A to B. And so try to keep, rather than keeping temporary products or even final products, try to keep the original products and the code that got you there. And that will make it easier to understand what you did and how you got to the data that you ended up analyzing. So not saving output is, I think, a key element of reproducibility. And try not to save data in non-proprietary formats. So these are data formats that are not where the layout of the data set is not publicly known. There are not too many proprietary formats out there anymore that are I think are commonly used as like there were before. But a lot of them, for example, products will store data in it because it's much more efficient in a proprietary format, but then that makes it difficult to transfer to another person. If that person doesn't have the same exact program, then they won't be able to read the data. And so using non-proprietary, even textual formats, maybe compressed, can be much better at can make your research a little bit, or analysis, more reproducible than proprietary formats. So there are a couple of pros and cons when it comes to the literate programming style. This is not the only tool that you can use to make your work reproducible, but literate programming is just one of the tools. And so some of the pros are that it forces you to put all the text and the code of your analysis in one place, so it occurs in a logical order. All the data and the results are automatically updated to reflect external changes. So if you have this live document, and if you make some changes, when you reprocess the document, it will automatically update itself to reflect any changes. So you don't have a situation where numbers will be out of date, or things will be mismatched, because the code will kind of automatically recalculate everything. Because the code is live in the document, in the sense that you have to run the code in order to produce the final document, that's the weaving process. You get this kind of regression test, so to speak, not like linear regression, but regression test to see so if there are any mistakes that you introduce into the analysis. If the code doesn't run, then you know you've made an error, you've introduced a problem. So the running of the live code will kind of keep you from introducing new errors into the analysis. Some of the cons when it comes to literate programming are that, of course, the text and the code are all in one place. And so in particular, if you have a lot of code, or if you have a very complex or lengthy analysis, then you're kind of like a human readable text is going to be mixed in with all this code, and it can make it difficult to edit the document because you have to somehow search through this whole document to figure out where the text is and amongst all the code. So that can be a problem for the author. Also, if your analysis is very complicated, and you have to reprocess this document every time you want to see a human-readable version of it, it can substantially slow down the process by which you build the document. So, what is knitr? So knitr is this tool that I'm going to talk about that can help you make these reproducible documents. knitr is an R package. It's written by Ihoi Xie, while he was a grad student at Iowa State. It's available on CRAN. If you happen to use the package RStudio, it's actually built into RStudio, and so it's integrated into the graphical user interface, and so you don't even have to obtain it separately if you're using RStudio. So it supports, for the documentation language, it supports something called R Markdown. It also supports LaTeX and HTML, so these are three languages that are commonly used. And then it can export to PDF and HTML, and you can also export to other formats if you're using other external tools like Pandoc. It's built right into RStudio for your convenience, as I just mentioned. So what do you need to use knitr? You need a recent version of R, you need a text editor. You can use the one that comes with RStudio if you happen to be using that, otherwise any old text editor will do. You need some support packages that are available from CRAN. These will be automatically downloaded if you use the install.packages function. You need some knowledge of one of the three documentation languages, so you either need to know Markdown, LaTeX, or HTML. And I'll talk about Markdown here since it's a fairly simple language to understand. So what is Markdown? Well, it's a simplified version of common markup languages. So LaTeX and HTML can be thought of as markup languages, where you take regular text and you kind of add things to add tags and other types of annotation to kind of indicate what you want to do with the text. One problem with markup languages is that they can be kind of like they can be very difficult to read because there's all this kind of tags and things that can obscure the actual text. So the purpose of Markdown is kind of simplify all that and make it easy to read just the text and only have a few kind of formatting elements that you need to enter into the document. There's no special editor required. You use a standard text editor, Notepad, whatever you want to use. There are simple, intuitive formatting elements, and you can get all the documentation at this website here. So, what is knitr good for in terms of creating reproducible documents? Well, personally, I think it's good for things like manuals. If you want to instruct someone on how to use a piece of software, short or medium-length technical documents, so you're explaining some technical concept. Tutorials, so if you want to, again, this is like a manual, but maybe more extended, a tutorial on some topic. Reports, they're especially useful for reports if you have to, for example, every week generate a report on some database or some data set. If you're running a study and you have subjects that are constantly being enrolled in the study, and then maybe every week you generate a report on, it has summary statistics about the study, then these kinds of live documents are very useful because you can recalculate all the summary statistics as you generate the document. You don't have to do it by hand and then stick it into a report separately. And then also for data pre-processing, so often it's useful if you're going to pre-process a data set to create a clean data set, to create a knitr type document where that documents all of the things that you do to the data set to make it clean. Maybe you remove some outliers, maybe you fill in some missing data, maybe you transform a variable here and there. All of that can be documented in this kind of knitr style where you simultaneously say what you did and then you actually do it in the code. What is knitr not good for? Well, in my opinion, it's not very good for very long research articles. So if you're writing a very complex, very involved analysis, like I said before, because everything is stored in a single document, it can get a little bit confusing to kind of edit this document if there's a lot of code and a lot of text. If you have very complex or time-consuming computations, then knitr is often not a good format because you have to recompile this document every time you want to look at it. And so if your computations are very slow, this will just kind of make everything slow. And furthermore, if you have a document, if you want to create a document that requires very precise formatting, so if you have a special layout and the pictures have to go here and the text has to go here or something like that, knitr is again not a super great tool for that because the formatting tends to be very ad hoc. So how do we create a basic knitr document? So I'm going to talk about this in the context of RStudio because I think it's the easiest way to do it. There are other ways to do this, so this is not really exclusive to RStudio, but the example that I'll show here will be in RStudio. So if you click on the new document button on the upper left, you'll see there are a variety of options, and you can click the R Markdown option to create a new Markdown file that'll have your text and code. So here's your a basic R Markdown document. So R Markdown is basically Markdown with R code embedded in it. You can see that what I have here is a basic symbol that indicates that I'm going to start a code chunk. So when I have the 3 backticks and then the curly braces and then an R and then a closed curly brace, that indicates that I'm starting a code chunk. So you can see I have 3 lines of R code here. I got set seed, I generate some random normal variables, and then I just take the mean. And then I close this code chunk with 3 backticks. And so you can see above this shaded area with the code, I've got text. So the title is my first knitr document, and then I say just a line of text that says this is some text, and then I say here's a code chunk, and then I start the code chunk. So in RStudio, you'll have this document open, and you'll have the code chunk and the text chunk there together, and the idea is that if you want to process the knitr document and create some human-readable output, so the idea is that you want to run the R code so you execute these 3 lines of R code, and then you want to put the output from that R code embedded in your document. And what's the output of this R code? Well, it's only one thing that happens. You calculate the mean. So it's going to generate the mean, and it'll be whatever the mean happens to be for that simulated data set. So it's very easy in RStudio. You can just push the knit HTML button, and it will automatically run everything for you. If you're not using RStudio, the way you can do this is you can load the knitr package with the library function. You can make sure your working directory is set to wherever the R Markdown document is located. Typically, R Markdown documents will have a capital RMD extension. It's not necessary, but it's just a good way to identify these types of files. You can use the knit to HTML function if you want to create a web page as your output, and it will automatically process the R Markdown file and run the R code and put the output within the file. And then within R, if you want to open this in your web browser, you can use the browse URL function. It will create a new file, the knit to HTML function will take your R Markdown document, create an HTML file with the same name, and then you can open in your web browser. So here's the output that you would get. This is the HTML format output that you would get. You can see that there's a title in large text, there's some regular text. The code is kind of in the shaded box. And then the output from that code is directly below it. Here you can see that the mean is 0.1089. So that's the output that came from the mean function. So in your so what happens here is that knitr takes your original R Markdown document, we can see on the left here, and it processes it into a regular Markdown document. And so you can see that the one thing that happens is that it takes your code, and then it reproduces the code in the regular Markdown document. But you can see that in the Markdown document there's one extra piece, which is the result of the code, which is down here at the bottom. And so the result of evaluating the R code is added to the Markdown document after evaluating the R code. So, so when you create, for a couple of things. First of all, when you create the new knitr document in RStudio, it will populate that document with some kind of generic filler text. So the first thing you probably want to do is just delete it, because that's not going to be relevant to whatever you want to do, most likely. Code chunks begin with the 3 backticks and the curly braces with an R, and you end a code chunk with 3 backticks. All of your R code will go between these markers. Now you can have more than one code chunk. You can have as many code chunks as you want, so you don't have to put all of the R code within the code chunk, but any R code that you do have goes in a code chunk indicated by the 3 backticks. You can have names for your code chunks, so you can name them so immediately after the curly brace and the R, you can put a name. It can be anything you want, and then you can close it with a curly brace. And then by default, the code in the code chunk will be echoed in the output document. So just like in the HTML document, you saw that it echoed the code and then it gave you the result of that code. By default, all the code chunks you'll be able to see in the document the code that was produced. So the processing of the knitr document happens in a certain way. First, the R markdown document is processed and creates a markdown document. Then the markdown document is converted to HTML, and then the HTML file is what you view in the final product. Generally speaking, you do not want to edit or mess with any of those secondary documents. You don't want to edit the markdown document or the HTML document, because those are automatically generated. If you edit them and then you reprocess the original document, all of your changes will be overwritten in the HTML file or in the markdown file. So only edit the R markdown file that contains the original text and the original R code. So here's another example. I've got my first knitr document, and I have my name there as the author, and I start a section called the introduction, and I say here's some text, here's a code chunk, and I name the code chunk simulation. And notice I added this option echo equals false. And so that indicates to knitr that I don't want the code for this code chunk to be echoed in the output document. I just want the result to show. So here I've got my level 1 heading indicated by the single hash, the level 2 heading indicated by the 2 hashes. I say don't echo the code. So now this is the output document. Again, you can see it looks like the original document that I had in the previous example, but I don't see the code. I only see the output, which is the mean. You can also hide the results too if you want to. In this case, it doesn't make too much sense, but you could do it by adding the results. The results equals hide option. And then when you see the output document, you see that all the text is there, but there's no code and there's no results. One of the nice things about a knitr document is that you can write sentences and text, and if you need to fill in a number or a statistic or some sort of computation in the middle of a sentence, you can just add that directly into a sentence. So for example, here I have a code chunk which computes the time, and using the systime function, and then I also generate a random number. Okay, and so now I can write a sentence. So that code chunk, I don't echo the code because I don't want people to see that code. What I want people to see is the sentence immediately after, which says the current time is, and then I'll just plug in the current time, and then the next sentence is my favorite random number is, and then I'll just plug in a random number. So here you can see the output is the current time is Wednesday, September 4th, and there's the time in 2013, and you can see my favorite random number is 1.1829. So that's how you can plug in computed variables or computed results in the middle in line with text. Another important aspect of any report probably is going to be some graphics. So you want to make plots of data or any sort of visualization. So you can easily add this into a knitr document. So here I've simulated some data, and then in the first code chunk I simulate some data, and then the second code chunk I make a plot. So I use the par function to set the the canvas with the margins and the LAS option, and then I call plot to generate the plot. And you notice I added an option here which adjusts the figure height, and so I say fig.height equals 4, which makes it a little bit squished more than usual, so it'll be a rectangular type of plot rather than a square plot. And so what knitr produces is a little bit interesting. It creates an HTML file through the processing. So you can see if you're familiar with HTML, you can see this is basic HTML. I've cut off a lot of stuff on the top, so I've just put the body in. And this is a basic HTML, and you can see that down here at the bottom you'll see there's an image tag, but rather than point to an actual file that's the image, it actually embeds the entire image into the HTML file itself. So you can see this is a base64 encoded image, and so actually this HTML file stands alone. It doesn't depend on any external image files. which is not necessarily the most efficient format, but it's actually quite useful because then you could take this HTML file, give it to someone else, and they don't have to worry about whether they have whether they have these other files or not, because everything's embedded. So here's the result. You can see I echo the R code. I have the result of the plot, and you can see it's kind of this rectangular shape, and that's my scatter plot. So another handy thing you can do in a knitr document is make a table. And often you want to make a table that summarizes the result of some calculation, like a regression model. So here I have a code chunk which loads some data, and I fit a linear regression model to it. Here I'm modeling ozone concentrations as a function of wind, temperature, and solar radiation. And I want to summarize the output from this linear regression model in a kind of pretty format, so not just your standard kind of R model format. So I'm going to use the xtable package, which is available on CRAN. You have to install it separately. It doesn't come with R. And I'm going to use the xtable function to summarize the fit, and I'm going to I'll print it to an HTML. You can see that in the resulting HTML output, after I process it with knitr, I get the code that I ran for the regression model, and it echoes the code. But at the very bottom here, I can see that I've got a table of regression coefficients, standard errors, t-values, and p-values, which is formatted in HTML, and so it'll be kind of in a prettier format rather than standard text mode. So sometimes you want to set options for the entire document, so these are called global options. And you want these options to apply to every single code chunk. So maybe if you never want to echo the code, for example, you want every code chunk to say echo equals false. Well, it can be a bit of a pain to have this specified every single code chunk, so you might want to set a global option for something like that. And so the way you can do that is you can create a separate code chunk in the very beginning of the document. Here I call it set options, and you can modify. There's a special object called ops_chunk. Which has a function built into it called set, and if you call that set function, you can set the global options. So here I can set echo equal to false, and I've set the result equal to hide. So by default, every code chunk in this document will not echo not echo the code, and it will hide the results. So here I've got some code chunks here. I simulate some data. I make a plot. But when I see the HTML output, let me go back. I can see, first of all, in the first code chunk, I overrided the default for the echo, so I want to echo equals to true. And then for the second code chunk, I don't want to echo the plotting code, and so I let the default occur. So here, the code that generates the data is echoed, but the code that creates the plot is not echoed. So some of the common options that are good to remember, of course you can always go back to the documentation on the knitr website. So the results can be specified as either hide or as is. As is means don't post-process the results, just show the raw results from whatever the output is. Echo can be true or false, so if you want to echo the code or not. For figures, usually you might want to modify the height and the width to be a specific type of size. So fig.height and fig.width are common options to set there. So one special case is when you have a code chunk and the computation takes a really long time to run. Now every time you process the knitr document to look at the HTML output, you're going to have to run this computation. So one strategy to avoid having to sit around and wait a long time is to cache the computation. And so caching computations can be very useful for kind of complex code chunks. And so the idea is that for each code chunk there's a special option called cache. You can set cache equal to true, and what will happen is that for that code chunk, the first time you process the document, it will have to run the code in order to figure out what the output is. But then what it will do is it will store that output on the disk, and so that the next time you process the document, as long as nothing has changed, it will load the results from the disk, which is typically a lot faster than having to redo all the computations again. So this will save you a lot of time if you're doing this over and over again. So if the data or the code or something changes, then you will have to rerun the code again. There's really no getting around that. And so the caching will kind of update to represent the new results. If one code chunk depends on another code chunk that was previous to it, this dependency is not explicitly tracked by default, and so you'll have to make sure that if a previous code chunk has a dramatic change to it, and a downstream code chunk depends on it, then you rerun everything so that the cache doesn't get mixed into it. Chunks with significant side effects may not be cacheable, so if the code in a chunk has some effect that kind of outside the document, then it may not be possible to cache that. So just to summarize, I've talked about knitr in this lecture, which is a useful tool for doing literate statistical programming. That will allow you to put text, code, and data and output all in one document. It uses a markdown formatting language, which is kind of very simple and easy to learn, and it creates HTML documents that you can view in any web browser. So I think it's a powerful tool for integrating text and code. As I mentioned before, there's pros and cons. It's not a perfect tool, but it may be useful to learn and for generating reproducible reports.